The electrical inspector is likely requiring the junction boxes to be installed at 18 inches above the floor to comply with the National Electrical Code (NEC) requirements for working space found in Article 110. This rule ensures that there is sufficient clearance around electrical equipment for safe maintenance and operation. Intrinsically safe wiring is a type of wiring used in hazardous areas where there is a risk of explosion or fire. Such areas require specific components and installation methods to minimize the risk of ignition. The magnetic switch being used may not meet the intrinsically safe requirements because it may not be explosion-proof or have other necessary safety features. To determine the specific requirements for intrinsically safe wiring in the shop, it is necessary to consult the relevant industry standards and regulations such as NFPA 70 National Electrical Code or IEC 60079.14 Electrical Installations in Hazardous Areas. These standards provide detailed guidelines on the design, installation, and maintenance of intrinsically safe wiring systems. Possible solutions include relocating the junction boxes, where the junction boxes are moved to the required height of 18 inches above the floor. Another possible solution is to use an intrinsically safe magnetic switch, replacing the current magnetic switch with an explosion-proof or intrinsically safe model that meets the relevant safety standards. Contact a licensed electrician who specializes in commercial electrical work and hazardous area installations to ensure that the security system meets all applicable codes and regulations. Electrical work should only be performed by qualified individuals to ensure safety and compliance. The National Electrical Code (NEC) Article 100 defines intrinsically safe equipment and wiring as equipment and wiring that is incapable of releasing sufficient electrical or thermal energy under normal or abnormal conditions to cause ignition of a specific hazardous atmospheric mixture. Intrinsically safe circuits are designed to operate with very low voltage and current levels, limiting the available energy to prevent ignition. Common applications for intrinsically safe wiring include chemical plants, refineries, mines, and other locations where flammable gases, vapors, or dust may be present. The NEC provides guidelines on the design, installation, and maintenance of intrinsically safe systems, including requirements for equipment selection, wiring methods, and grounding. When installing intrinsically safe systems, it is crucial to follow manufacturers' instructions and relevant industry standards to ensure the safety of personnel and equipment. Specific requirements for intrinsically safe wiring can be found in Articles 500 through 506 of the NEC, which cover hazardous locations. These articles classify hazardous locations based on the type of hazard present, such as flammable gases or combustible dust, and specify the requirements for electrical equipment and wiring in each location. The NEC also requires that intrinsically safe equipment be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, all to ensure that it meets the applicable safety standards. Proper grounding and bonding are essential for intrinsically safe systems to prevent the build-up of static electricity and to provide a path for fault currents to flow safely to ground. Intrinsically safe barriers are used to limit the voltage and current that can enter a hazardous area, preventing ignition of flammable substances. These barriers are typically installed in the non-hazardous area and connected to the intrinsically safe equipment in the hazardous area. Regular inspection and maintenance of intrinsically safe systems are necessary to ensure their continued safety and reliability. This includes checking wiring connections, verifying grounding and bonding, and testing the performance of intrinsically safe barriers. The use of intrinsically safe wiring is not limited to new installations. It can also be used in existing facilities where hazardous conditions may be present. In such cases, a thorough hazard assessment should be conducted to determine the appropriate level of protection required. When working with intrinsically safe systems, it is important to use appropriate tools and equipment to avoid damaging the wiring or components. Special care should be taken when making connections to ensure that they are secure and properly insulated. Training is essential for personnel who work with intrinsically safe systems to ensure that they understand the hazards involved and the proper procedures for installation, maintenance, and troubleshooting. The NEC also provides guidelines on the use of intrinsically safe systems in specific applications such as motor control circuits, instrumentation systems, and communication networks. These guidelines address the unique challenges associated with each application and provide recommendations for ensuring safety and reliability. Intrinsically safe systems are designed to provide a high level of safety in hazardous locations, but they are not foolproof. It is important to follow all applicable safety precautions and to consult with qualified professionals when working with these systems. The selection of intrinsically safe equipment should be based on the specific hazards present in the location where it will be installed. This includes considering the type of flammable substance, its ignition temperature, and its concentration in the air. Intrinsically safe wiring must be installed in accordance with the manufacturer's instructions and the applicable codes and standards. This includes using the correct type of cable, making proper connections, and providing adequate support and protection. Regular testing of intrinsically safe systems is necessary to ensure that they are functioning properly and that they are providing the intended level of protection. This testing should be performed by qualified personnel using calibrated instruments. The documentation for intrinsically safe systems should be maintained in a safe and accessible location. This documentation should include information on the system design, installation, maintenance, and testing. Intrinsically safe systems are an important part of the overall safety program in many industrial facilities. They help to protect workers and equipment from the hazards of fire and explosion. In addition to the NEC, other standards and regulations may apply to intrinsically safe systems depending on the specific application and location. These standards may include those published by the International Electrotechnical Commission (IC), the European Committee for Electrotechnical Standardization (CENELEC), and other organizations. It is important to stay up to date on the latest codes, standards, and regulations related to intrinsically safe systems to ensure that they are installed and maintained in accordance with best practices. The use of intrinsically safe systems is not limited to electrical equipment and wiring. It can also be applied to mechanical equipment, such as pumps, valves, and actuators. In these cases, the equipment is designed to prevent the release of energy that could cause ignition. Intrinsically safe systems are often used in conjunction with other safety measures, such as ventilation, fire suppression, and explosion protection. These measures work together to create a safe environment for workers and equipment. The cost of intrinsically safe systems can be higher than that of conventional systems, but the benefits in terms of safety and reliability can outweigh the costs. It is important to consider the long-term costs of ownership, including maintenance and testing, when evaluating the cost-effectiveness of intrinsically safe systems. Intrinsically safe systems are a valuable tool for preventing fires and explosions in hazardous locations. By following the applicable codes, standards, and regulations, and by working with qualified professionals, it is possible to design, install, and maintain safe and reliable intrinsically safe systems. In the context of the initial question, the inspector is likely concerned about the potential for the magnetic switch and its wiring to create a spark or generate heat that could ignite flammable materials in the shop. Even low-voltage systems can pose a risk if they are not properly designed and installed. The requirement for 18-inch height for junction boxes is related to providing adequate working space around electrical equipment, as stipulated by the NEC. This working space allows electricians to safely access and work on the equipment without being obstructed. In addition to the height requirement, the NEC also specifies minimum dimensions for the width and depth of the working space, depending on the voltage of the equipment and the presence of energized parts. The working space must be kept clear of obstructions, such as storage materials or equipment, to ensure that electricians can safely perform their work. The NEC also requires that the working space be adequately illuminated to provide sufficient visibility for electricians to perform their tasks. Furthermore, the NEC mandates that access to the working space be provided with a door or gate that is at least 24 inches wide and 6 feet 8 inches high. The door or gate must be able to swing open at least 90 degrees and must be equipped with a self-closing mechanism. These requirements are intended to ensure that electricians have safe and easy access to electrical equipment for maintenance and repair. When installing electrical equipment in a shop or other commercial building, it is important to consult with a qualified electrician to ensure that all applicable codes and regulations are met. A licensed electrician can assess the specific requirements of the installation and provide guidance on the proper selection and installation of electrical equipment and wiring. In the case of the security system installation, the electrician can help to determine whether the magnetic switch meets the requirements for intrinsically safe wiring and can recommend alternative solutions if necessary. The electrician can also ensure that the junction boxes are installed at the proper height and that all other electrical work is performed in accordance with the NEC. By working with a qualified electrician, it is possible to ensure that the security system is installed safely and correctly, and that it meets all applicable codes and regulations. It's also important to remember that electrical codes and regulations can vary depending on the location. Therefore, it's essential to consult with local authorities or a qualified electrician to ensure compliance with all applicable requirements. The NEC is a comprehensive set of standards that covers a wide range of electrical installations, including residential, commercial, and industrial applications. It is updated every 3 years to reflect the latest advances in electrical technology and safety practices. Compliance with the NEC is essential for ensuring the safety of people and property from electrical hazards. The NEC is adopted by many states and local jurisdictions in the United States, and it is also used as a reference standard in other countries around the world. In addition to the NEC, other standards and regulations may apply to specific types of electrical installations. For example, the National Fire Protection Association, NFPA, publishes standards for fire alarm systems, sprinkler systems, and other fire protection equipment. These standards provide detailed requirements for the design, installation, and maintenance of these systems. It is important to consult with qualified professionals to ensure that all applicable codes, standards, and regulations are met. The information provided here is for general guidance only and should not be considered as a substitute for professional advice. Always consult with a qualified electrician or other professional before performing any electrical work. Remember that electrical work can be dangerous, and it should only be performed by qualified individuals who have the necessary training and experience. Safety should always be the top priority when working with electricity. In addition to ensuring compliance with codes and regulations, it is also important to consider the long-term reliability and performance of electrical equipment. Selecting high-quality equipment and performing regular maintenance can help to prevent problems and extend the lifespan of the equipment. Regular inspections can also help to identify potential problems before they become serious. By taking a proactive approach to electrical safety and maintenance, it is possible to minimize the risk of electrical hazards and ensure the reliable operation of electrical systems.